Okay, I'm going to record question number 11. Number 10, I said it's similar to number 8, 9, so you can do it. And question number 11. Use the accompanying decision tree to complete part A through C. Okay, identify the missing probabilities. What do we have here? First of all, I'm going to take a picture so I can work with it because I'm going to open the notebook in my iPad, so do calculation and you can see. So I recommend you also take a picture so you can follow to what I'm doing. All right, so first we need to find a probability of A3S2. Let me work on it. Um, so this is what we're gonna do in if you look at let me show actually. If we open here, see S1, it gets probability 0.8. I zoom it. S2 doesn't have probability, so I need to find that one. So S2, it's going to be 0.2, right? Because if 0.8, so total is 1, 1 minus 0.8, S2 is going to be probability 0.2. Write down somewhere. And then for A4, S1 is 0.8. That means the S2 also going to be 0.2, 1 minus 0.2. And for A5, so S2 is 0.2. That means S1 is going to be 0.8. Okay, so this is what I'm going to do. So I'm going to find probability. So probability for A3 and S2, it's going to be 1 minus 0.8, which is equal 0.2. Next, probability A4. I'm writing down the same path that I just read for you, showing on the picture. And S2, it's going to be 1 minus 0.8. Since S1 is 0.8, so minus 1 minus 0.8, 0.2. And probability for A5, S1, I'm sorry, it's going to be equal 1 minus 0.2 equals 0.8. Now, this is the first answer, 0.2, 0.2, 0.8. Let me place it. So it's going to be 0.2, 0.2, oh, 0.2, and this is 0.8. Okay, fantastic. Next, evaluate the decision tree, expected payoff. How we are going to identify our expected payoff. We are going to identify the following way. First of all, the all possible payoffs is equal probability of xe. I is from 1 to n, total amount, and which is equal 1. Okay, let me start doing the math. What do I have? Probability for the missing values. 1 second. 1 second. Yeah, for missing values, I'm going to do. In my case, was missing probability A3S2, A4S2, and A5S1. And I'm going to identify expected value for these branches. Okay? So let me see, my A free expected value for V free is equal. I have probability 0.8, it's given, you can look at the picture, times the value is the value is 0.8. Let me open this for you so you can see. Look, A free, I have S1 0.8 and the value is $8, so probability 0.8 multiplying by $8, and then plus S2 for A free, it's $2 and the multiplying by negative $4. Okay, that's what I'm going to do. Let me see. So the expected value for A free is going to be equal A8 times $8, and then plus it will be the 0.2 times negative $4. This is this negative 0.2. And what do we have? We have 6.4, right? Minus 0.8, correct? Okay, so that's gonna be 5.6. So next one, evaluating for branch 4, I have for S1 probability 0.8 times $6. Okay, I'll put $6, and then minus, so 0.2, because 1 minus 0.8 is 0.2, and because it's negative $1, I just put negative there already, times $1. Okay, and it's going to be 4.8 minus 0.2 equal 4.6. And lastly, evaluating for evaluation for A5, it's gonna be 0.8 times $4, and then plus 0.2 times $1, and that's gonna be 3.2 plus 0.2 is equal 3.4. Okay, so the maximum here is 5.6, right? There, and then we are going to take a max between A1. How much was our A1? Let me see. A1 is 2.65. So, because and that's a total, right? A1 of everything. So I'm going to compare if I have in my branch value that is greater than total, so it's that maximum, it's going to replace that total, which means I'm going to do maximum between 265 and 5.6. Obviously it's going to be 5.6, and that's going to be my expected payoff maximum. It's going to be maximum value 5.6. Bingo. And the alternative should be chosen, since which one was that? We chose 5.6, that's for A free, right? So alternative, we're gonna choose A free. Oh, we have there one more, right? Hold on, let me see. This is also for CB greater. Okay. A3, A4, let me see. Since our maximum is A3, so it's gonna be A3 and A2. All right. Very good. Moving to the question number 12. Well, question number 12 is the same way, so let me solve it real quick. So what do we have? A1, S2, we have 0.7, 0.3. So S2 0.3, A2 is gonna be 0.7, 0.3. Both of them are going to be 0.3. Because it's given 0.7, remainder is 0.3. Okay, well done. Expected the payoff. Okay, let's see how we're gonna work out this one. Let me first take a picture of that tree, decision tree. Okay. All right. Then going back to calculation. So what do I have for value for tree A1? I'm going to have 600 times 0.7, and then minus, since I have 600, and for 0.7 left over 0.3 times 600. Why I put negative? Because 600 is negative. And I'm getting 42, 420 minus 180. And my result is going to be 140. Okay, next expected for branch 2, it's going to be, so 0.7 times it's $700, and minus, it's going to be 0.3 times 500. Okay, I put already negative in multiplication, so I don't need to write 500. Okay, so 0.7 times 700 is going to be 490, and minus 150. Yes? Okay, and we are going to have 340. Double check so not to do silly mistake. Yeah. All right. So since let's see, the maximum between EV1 and EV2, it's going to be EV2, right? Max of 140 and 340 is going to be 340, which is the expected value of branch A2. Now, going back to my decision tree, since A4, A5 is not given probability, so I'm going to assign the maximum between A1 and A2, and maximum was 340, I believe, so I'm going to assign for branch A3 340. Let me double check one more time. Yes, 340. Okay, let me type it in. Well done. And let's do question number C. What alternative should be chosen? Looking at our maximum 340, that's EV2, which means branch 2. I'm typing here 2. Checking, and we have good job. Okay, And moving to question number 3, it is given the mean of normal distribution. How can you find the median? It's gonna be, when it is normal distribution, the mean is equal to the median. Why is that? Because there is no skewed data. Neither mean is skewed nor median is skewed. So both the median is not skewed. I'm sorry. So if it's normal distribution, that mean it's not skewed. Therefore, we don't have too much a smaller number or too bigger number. Therefore, it's gonna be equal, median and mean. Okie dokie, I'm done.